today.
Reading a good book. This is password 125?
Right behind you.
This says 24. Is that?
Oh, well. You're right. Give me just a sec. Let me see. I need to find one person out. Okay, how about 23. 23, she's absent today, so.
See you, Townsend. Ew!
See you tomorrow.
That's pretty. Super nice. Where did you see that person? Yeah, I just looked at it. It was amusing. I think it was like really late about the options.
For one of the assignments that I re-uploaded for the credit, I took a picture of only one page because there was one problem, and then I submitted it. Should I like give you the whole thing as well? There was only one problem that wasn't completed.
Yeah,
but
I wrote you back on one of them.
Mhm.
So the thing is, when you just submit the one page, I can't remember like.
Okay, yeah.
You know what I'm
that from
saying?
you.
So
Yeah.
if you had scanned all of it in, I don't need the hard copy and the Google Classroom. It's just either or.
All right.
But in that case, I need to see that you did the rest of it too.
Okay.
So
Yeah, sorry about that.
No, it's
I just
fine.
did it and then I didn't even think about it, so.
it's fine. It's first of the year stuff.
Sorry.
Also, sometimes I forget. Like, so many people in here had me as a teacher last year that sometimes I forget to. Like,
Yeah, sorry. I've never had you do it.
No, that's fine. I understand.
Thank you. You trying to get him back for what he did to you last week?
I'm trying to show him that.
Yeah, he's trying to study in case it ever happens to him again.
No, I can solve it. I can solve it.
He has PTSD now.
Looks like it.
It's been haunting him.
I can solve it, I can solve it.
He came by and solved it yesterday too, so
Ah.
it's an everyday thing.
Well, I used to have a cube, but I left mine, so.
You had one like that?
Yeah.
I'd like to get a lot more of them, but somebody stole one of mine a couple of years ago.
They're expensive.
Yeah. I wouldn't even mind paying full price if I knew I was going to have it the rest of my teaching career, but when people start taking stuff, I don't make enough for that.
A little birdie told me it was your birthday. Happy birthday!
Thank you.
Happy birthday.
Thank you. I hope y'all brought my present.
Did we not get 14 yet?
Oh, 14 is one of the handouts on the desk up there.
Oh, okay.
It's that one.
Okay.
Well, I mean, I went over the test review, I just finished it.
Finishing up this test. I was advising.
Whoa, you're doing how?
It's hard. Not too bad so far, but I know it'll get harder.
Okay, as you guys come in, there's 3 assignments I'd like to give you credit for if you didn't put those in Google Classroom. Also, any late work, incomplete work that you wanted more points for needs to be turned in also.
Ready? I actually read.
We ever turn into?
We have not turned in pen yet.
Are you going to?
At some point, no. It's not a concern today. I will already have a stack of papers 2 inches thick from these, so.
What's with these?
You want one? But only if you promise to make 100 on your test.
I promise.
Promise.
But that's on how you grade it.
Okay, that's good.
All the way.
I found this. It's Everett's. I guess he left it in here.
Okay, I'll get it to him. Thank you. Okay, and then clear off your desk, please.
I can go use the restroom real quick.
Not during the first 10 minutes. Do that on your way to class.
Well, I couldn't. I leave my advisory and I get here and it's already 11:39.
I don't know.
Is it possible I could just go or not?
In a few minutes. Okay, then clear off your desk so we can get started. Okay, I'll give you some general directions in just a minute, but let me go ahead and get this passed out to everybody first. This is no calculator. Make sure I have your assignments and any late credit, late work stuff that you wanted more points for before you get started here. So I'll try to get that to you later today or later this period. I mean, before you start. Okay, so as I said, this is no calculator with one exception. There is an FRQ on the back. I don't think you should need a calculator for it, but it says that you can use a calculator. So at the very end, when you're about ready to turn in your test or your quiz, if a calculator will help you with your FRQ, you're welcome to get it out. Use it for that. Okay, I missed anybody? Okay, I did mention that this would go in the grade book as a 20-point major assignment. The test doesn't have the point values written on there, so I will go ahead and tell you. The FRQ on the back page is worth 9 points. FRQs are always out of 9. That's how your AP exam does it.
and every other question is worth the same at 1 point apiece. Now you'll notice that 9 points for the FRQ and then 13 others actually makes 22, but 2 of them are just freebies. So you can actually miss 2 questions and still make 100 on this one. So just a tiny bit of a curve, I guess, since a couple of these are more in line with AP level questions.
Is it just for this quiz or for future ones as well?
They'll each be different. A lot of our quizzes and tests actually have a bigger curve, but they have a bigger curve because there'll be more AP questions on them, which makes it harder. So it's always proportional to the difficulty. So obviously, if it's multiple choice, at least make a guess. There was somebody in 3rd period last Friday who just didn't even answer a question, and it was one of the multiple choice questions. So he could have at least guessed. He probably should have checked his work before he turned it in. But don't feel rushed. If you need to borrow a calculator from me when you get to the FRQ at the end, I've got calculators up here. Just put them back when you're done. Your quiz goes in the basket up here where you gave me all your homework. And when all of the quizzes are done, I will let you know and we'll move on. So if you're one of the first few people finished, just find a book to read or find something else to work on, please. Something quiet. Jonathan, you can use the pass now.
Sorry to interrupt for just a second, but I graded your papers that you guys turned in. So if you're one of the first people to finish, and there's not already somebody over here, please just take the pages with your name on it so that you get those back. It'll be right here with you. If somebody's there getting their papers out, you can just sit down and go back when no one's up there.
And if you finish later and you don't have time to do that today, that's fine. They'll be there next time too.
Mr. Johnson, you think you could fill this out?
Yep.
Thank you. Good job, doing.
Did I already do yours?
Last year.
Oh, okay.
Thank you.
Could you do this also? Sure. I got a pen. Give me a few minutes. I'll bring it back. Okay.
Is this from last year?
It is. It was, I don't know. You were gone today. I passed them back or something.
I did, thank you.
Eternity too.
and thoughts.
You can use a calculator for the last part of the question.
Just the last part. I want to know the answer to this, and then I want you to tell me this. Evaluate this. Tell me what that's equal to.
Yeah.
Okay. And then explain why you think that's the answer, and you should be saying something about limits.
The word statements.
Mm-hmm.
Okay.
You need to explain that.
Okay. Let's still have these things. Just one or all three still?
I can't tell you that.
Okay.
Whatever you think. keep it down, please. Now I'm getting louder. I think we might have one or two people still working, so if that is you, that's fine. Go ahead and keep going quietly for a few more minutes. The rest of us, we need to move on a little bit here. So before I talk about what's next and for us to start the other handout, so these major assessments like this, we don't pass these back to stay in your binder. So in place of that, that's one of the two handouts you guys picked up today. You should have numbered that one as number 14. It was not numbered for you. And it's just the test reflection. So I don't look at those, so you should answer honestly. You know, if you only studied 10 minutes and you should have studied 10 hours, you know, that's fine. It's for your information. But especially those of you that did this with me last year in pre-calculus, it's a little less important in pre-calculus. There's one section on that reflection that asks you about, like, what do you wish you had memorized, or what type of questions you wish you had practiced more. You really, really, really should answer that with fidelity. It's obvious to you now because it's been the thing you've been doing the first few weeks. But in April, when we're reviewing for the AP exam, and we haven't thought about many of these limit type of questions since then, you are doing yourself a favor by writing those things out. Giving yourself a little bit of a cheap shoot. I do have quite a few of those in the grade book already. I should have the rest of them graded and in the grade book before I leave, but I don't let anyone see theirs or ask questions about theirs until they are all made up. And I have one person from second period that was absent today. So depending on when he makes it up, you can come and see yours. Now, if you check your grade online and you see that you made 100, you should probably still make a point to come by and see it, because remember, 2 of the points were free. So you might got 20 out of 20 in the grade book, but you might have missed 2 questions. So, I mean, I'd be happy with that, but you should still see what questions you missed. So 14 goes in your binder in place of that quiz. We'll probably also look at these together in December before your final exam. We do a final exam for first semester that is non-exemptable, but we don't do a final second semester unless y'all are being lazy or something, and then I'll give you one to get more work out of you. But okay, so again, I haven't finished grading y'all's, but my third period and my second period were around 90% average, give or take a couple percent. So hopefully you also felt good about it. The good news is if you don't like limits or you feel like those are unusually hard, the good thing is the rest of this semester is not dependent upon those. You can be very bad at limits, you can not understand limits, and you can still be very, very successful in calculus. You're going to see one little thing on assignment 15 about why we needed to do limits at the beginning of the year. But for the most part, that stuff does not carry throughout the rest of the year. But the other side of that is we are going to start derivatives now. We're going to start talking about what a derivative is. And this is super important because pretty much the rest of the semester is how to take derivatives by hand, memorize a few derivatives, learn how to take derivatives in your calculator, learn what a derivative is. We're going to do most of that here in just the next couple classes. And applications of derivatives. So where in the real world would you care to know what a derivative was and what does it measure and that kind of stuff. But then even second semester we do integration, and integration is just the inverse of derivatives. So just like you learned how to do division after multiplication, you learn how to add and then you learn how to undo it. So calculus is kind of the same thing. The next step is learn derivatives this semester and then learn to undo it with integration next semester. So I say all of that to let you know that this stuff is going to be extra important. So the other handout that you picked up should be number 15. I don't remember if I had that one numbered for you or not. If I did not, please number it. So we need to talk about what a derivative is, how it's unique, and as far as trying to do things that you haven't done before. So the first two of these in question 1, before I just flat out tell you what that stuff is, these are both linear equations. This is y equals mx plus b, and this is point slope. Y minus y1 equals m parentheses x minus x1. If you don't know, or if you are not familiar with point slope, now's the time to become familiar. We pretty much exclusively use point slope. Slope intercept, the mx plus b is actually more work, and it's not any better, so we tend to use point slope. But if we're talking about a linear line, and I want to know slope, well, you're just looking at the right part of the equation. If the slope is 3, the slope is 3. If the slope at the beginning of the question is 3, the slope at the end of the question is 3. Because linear, it's what you guys think of as straight lines. Whatever the slope is, the slope is. But in the real world, not everything is just a bunch of straight lines like that. In the real world, you've got lots of curvature to it. So something like x squared. What do you think the slope of x squared is? It's a harder question, right? Because it's not always the same thing. So it depends. If x was 2, do you see at that instant the slope is something positive? But maybe at x equals negative 2, at that instant the slope looks like it is negative something. What about at x equals 0? What does the slope look like it is at that instant? 0. So if your function has curvature, then your slope depends upon the x value. So this is the idea that starts to come in, that is derivative. Derivative and slope basically mean the same thing. Slope kind of implies you're talking about a linear function, whereas derivative means you can be talking about any function, but derivative is basically the same thing as slope. So before I just tell you what the definition of the derivative is, I will show you where it comes from. You don't have to copy this down, but again, this thing that we're going to be referring to sometimes, just so you don't think it was just pulled out of the air. But if you have some function with a lot of curvature to it, let's say I want to figure out the slope at this instant. Sometimes we draw on this little tangent line to try to visualize that. Well, if I want to know the slope at this instant, what I could do is take this guy's point, I'll call it generic xy, or xf of x. I'm going to scoot over a little bit to the right and take a second point. And how much we scoot to the right, we call h. So this new point, what would the x value of this point be? Very good. Whatever this was, plus h. And then the y value is going to come from plugging in x plus h into the function. Now, if you take these two generic points that are not defined by numbers, but I can find the slope of these two lines using our old slope formula. Subtract the y's for the rise, subtract the x's for the run. But now I'm going to plug these in. So y2 minus y1 over x2 minus x1. Notice in the denominators, x minus x goes away, and what's left over, this is called the quotient rule. So those of you that did pre-calculus last year, there was one quick little unit where you practice using the difference quotient to simplify some stuff. The difference quotient is really just the slope formula with generic points, x, y, and x plus h, f of x plus h. So the last part of this is, if I want to know the slope at this time in red, ideally, what would I want h to be? Okay, we can do better than that.
2.
Okay, let's say h is 1, so whatever this is, 1 closer. 2 is even further away.
0.
Ideally, it's 0. You want this second point to be as close to the first point as possible, right? So in mathematics, we can do that. I can't say h can be 0 because that would be division by 0. But what we can do, and the reason why we have to start this class off with limits, is we can say the limit of that as h approaches 0. So as this second point approaches the first point, as it gets closer and closer to it, then the slope formula, which is really the difference quotient, ends up being representative of the slope at that instant. So you don't have to prove this or derive this or anything. I'm just showing you where it comes from. But I already had it typed up for you on your page here. Somewhere. There we go. So here's the difference quotient. And then when you take the limit as h approaches 0, all of a sudden you have the definition of the derivative. So again, that kind of looks like this. We use a tangent line to kind of visualize that derivative. A tangent line is a line that touches your circle or function exactly at one point, not more, not less. So a tangent line is kind of a visual of the slope at that instant. Now, you also need to start being familiar with some of this notation. So when we say f of x, we are talking about the function f. And if we do this, if we put this little prime mark here, that now represents the derivative. Very different things. A function versus his derivative are measuring two different things. The function is measuring something, and the derivative is measuring the slope of the function. So just take notice that that one little tick mark completely changes what we're talking about. This means derivative. Okay, so next up, I'd like us to talk about how question 3, 4, and 5 are similar and different. So question 3 ultimately is asking you to find the derivative, aka find the slope of this line. So this is quadratic. We know quadratic's got some turning points. It just depends on the x value that you're looking at, which means our slope, our derivative, is going to have x's in it. So until next class, the only way we have to do this is with the definition. So this is actually the only question all year that I make you do the derivative using the definition. So the definition says we're going to take the limit as h approaches 0 of f of x plus h, which just means everywhere there's an x, everywhere there's an x, you plug in an x plus h. Then you subtract the entire function, and you put it all over h. Now, the only reason I don't make you practice doing the derivatives by the definition, except for this one problem in your notes, is for whatever reason the AP exam doesn't test you on this. So, but when I did calculus in college, I very much got tested on it. In fact, I had a professor that she told us before the first test that you finding the derivative by definition will be on your first test, and it will be on every test all semester long. And she actually did put it on every single test. Okay, and then since this is a polynomial, we can simplify some of this. So we can FOIL this. Make sure not to just square the x and square the h, but actually x plus h times x plus h. We could distribute a -4. We could distribute this negative. This is where you guys might remember doing this now. Does it kind of seem familiar from pre-cal? Yeah. Most of this stuff goes away. +3 minus 3, +4x minus 4x, x squared minus x squared. In fact, everything in the numerator goes away except for some stuff, and they all have something in common. 2xh, h squared, and minus 4h. What do those all have in common? Okay, so imagine factoring that out as a GCF. Now it should seem like some of the questions you did on today's quiz. If you're trying to evaluate this, you could have plugged in 0 from the beginning, by the way, but you'd get 0 over 0. We rewrote this with algebra, and then before direct substitution will work, what do we always have to do? Yeah, something's got to cancel. In this case, times h divided by h. Then do direct substitution, and it looks like the derivative is 2x minus 4. In fact, let's use our new notation here. F prime of x is 2x minus 4. So again, this is it's like a formula that tells me the slope of this original equation. If I want to know the slope when x is 0, you're just going to plug 0 into the derivative, and then you know the slope is -4. If you want to know the slope when x is 10, you can plug 10 into the derivative and figure out that the slope is 16. If you want to know the slope at x equals 1, like question 4 is asking, you just plug a 1 into the derivative and you get -2. So it makes sense that the slope should change based on the x value, so you should have an x in your derivative. But if you're asked for the derivative, you have to find the derivative. If you're asked for the derivative at a point, you just plug that x value into the derivative. And then if you want the equation of the tangent line, you should be thinking about point slope Okay, and we want to know when x is 1. So I can plug in a 1 for x, but you're going to typically have to put some thought into what is m and what is y1. So how can I go about figuring out what m is? What is the slope when x is 1? Right, we just did that right here. If you want to know the slope, you plug the x value into the derivative. But if you want to know the y value, that's talking about a point. That's what you're used to doing. You've been doing that since Algebra 1. If you want to know a point, you plug 1 into the function. 0. So you could say that would be the equation of the tangent line. But that's important to put some thought into what you're plugging it into versus what kind of information you're trying to get. You want slopes, you plug into the derivative. You want points, you plug it into the function. And sometimes we talk about second derivative. Sometimes you plug things into the second derivative for more information. But that's for another day. So what we just found, I want to graph it real quick just to help you visualize it. So here is the function of the last 3 questions. and we were trying to find the derivative at x equals 1, which means the slope at that exact instant. So do you see how it's supposed to be something negative? And we said it was -2. And then in step 3, we found the equation of the tangent line. So if I graph it as well, what should happen, if that's correct, is it should touch it only at x equals 1, and it should be like a visual of the slope at that one instant. So the fact that that looks like what it's supposed to represent is a good way to make me feel good about that answer. Okay, so we checked that with the calculator, with graphing, but again, I like to point out, because this is basically the same way. Sometimes you're asked to find the derivative, sometimes you're asked to find the derivative at a certain value, and sometimes you're asked to pull that information into an equation, but it's 99% the same work. Okay, so if your AP exam does not expect you to do this and find derivatives using the definition, what they do expect you to do is use the definition of a derivative with a little bit of pattern recognition, and they do give multiple choice questions like this that we have to process with process of elimination. Okay, so the standard definition is this one. You don't need to memorize this before class on Thursday, but you will need to memorize it. And they also talk about this one as well, which is the alternate form of a derivative. You'll also need to memorize that one also. Now we'll practice just a couple of these before we call it quits today, but I will have you practice this later on too. 4 examples is not quite enough. But what you have to look at is, so here's the standard definition. The standard definition always has limit as h approaches 0. You can think about up here supposed to be the function, over here supposed to be the function with x plus h plugged in, and it's always over h. Whereas if it's the alternate form, the top left should be the function, and then a, you might actually change this to an a. A is the value that you're trying to take the derivative of. Okay, so look at this question down here. I know sometimes these don't print off the grade, but does this look more like the standard definition or the alternative definition? Okay, so once you recognize it looks a little bit more like the alternative, then in your head, you're trying to compare it to the alternative form. I like to write it next to it. It makes it a little bit easier. I can see that A is supposed to be E. And what does A represent? A is E for this question, but what does A in these problems tell us? It's the value that you're trying to take the derivative of. So notice D is saying the derivative at 0, and B is the derivative at 1. A and E or A and C are still fair game. They're saying the derivative at E, the derivative at E. The fact that A is E, that's how I know that. Okay, also, what is this supposed to be? What's the natural log of x in this question? No, you're not plugging in E to that. I'm just getting you to try to match it up to this. It's your f of x. So you go through here. There was 2 choices that said f of x was natural log of x, but there's only one choice where all of that is true. So again, you got to kind of figure out which one it looks like, and then use that as a clue to try to piece together what was the function, what are you trying to take the derivative of. Okay, let's look at 2 more. I'll do this one for you, and I'll have you try the next one, and then we'll do today's puzzle. Okay, so glance at the top. Does this look more like the standard definition or more like the alternative definition? standard. So h approaches 0, and you've got h in the denominator. So here's what the standard definition says. And again, this is supposed to be our clue in here. So it's supposed to be divided by h. Okay, well, we've got that. That doesn't really help us too much. But this one's a little bit harder. Oops. This is supposed to be this. Now, what can be frustrating sometimes is sometimes they plug in x's and sometimes they plug in numbers. Numbers of what you're trying to find the derivative of. So this is the square root of x plus h. So when I look at that, I can see that the original function, before you put the plus h there, was square root of x, and in place of x they're putting 9. So the reason that they're putting 9 there is because that's what they want the derivative of. Now, over here, notice this is also not in terms of x. This is supposed to be the function, which I think is the square root of x. But if they're wanting the derivative at 9, they're not calling this the square root of x. They're calling it the square root of the x value that they are trying to find the derivative of. Just like they plugged in a 9 for x here, they're plugging in a 9 for x there and simplifying. So you really could have stopped right here. If you could at least identify that the original function was square root of x, it was the only one that had that. So that narrowed it down. Okay, so try one more for me. Read the question on this one. Think about which one of the two forms it is and try to pick off a couple that don't look like it's correct. And then we'll check that and then quit for today. We didn't do this in pre-cal last year, did we? For some reason I felt like we did, but must have just been in calculus classes. Okay, so again, they can change it up a little bit, and this time instead of giving you one of these as the question and then trying to figure out this is the answer, they've flipped it around. But when you looked at all of these choices, did it fit more of the standard or alternate form? Alternate. So the alternate says this. Again, I know you have it at the top of your page, but I don't want to flip back and forth. So right here is supposed to be the function, and they told us what the function is. So is that choice A? Nope, because of that plus pi. Could it be choice B? Could it be choice C? Could it be choice D? So simply just knowing that it's the alternate form, and in the alternate form the function is supposed to be sitting here in the top left, already gets you down to a 50-50. Okay, x approaches, so this would be a. A is the number you're trying to find the derivative of. So x approaches pi, but they both have that. X minus a is going to be x minus pi, but they both have that. Okay, and then this is supposed to be the derivative at a. I'm sorry, the function at A. So here's the function, and what is A? Okay, and what is the cosine of pi? Actually, wasn't this on your test? Man. Okay. Let's say more of you got it right on the test than y'all are saying. Okay. So they could, in the top right, put this, or they could put this. It just depends on how they feel like doing it that day. But that was choice D. Choice D was the only one where everything was consistent. This, they just put a pi there. They didn't put pi into the function, so that was messed up. So those aren't terribly difficult, but you do have to practice 10 or 20 of them before you kind of feel like you've got the hang of it. So all I want you to do for homework, please, is just scan the stuff we talked about on 15. That'll make class a little bit easier on Thursday. You don't have to do anything extra there. There's no other homework, but just refresh yourself on all that stuff so that that's familiar. And okay, I think I shared this logic puzzle with you. Yes?
Why did you even have this?
Why did I have this?
It's from like May.
Huh?
It's from back in May.
Yeah. So, it's your paper, ain't it?
I mean, I think you trashed it.
Did I show you this one?
No.
Okay. No pressure, but I think y'all are the last class to see this one. In my other classes, there's been at least one person to figure out how to do it. So, we'll see if y'all can come up with something. Any ideas?
You feed the rat 2 bottles at the same time, and then if it dies in 10 hours, it's one of those bottles. And then you feed another rat the other 2.
You only got one rat.
Oh, 1 rat only?
Yep. Because if you have unlimited rats, you just
Okay.
just
Well then, if you feed the rat 2 bottles of milk, and it does die, then it's one of those bottles.
That's
so
true.
You don't have to feed. You can drink the other 2, and then wait.
What if he doesn't die?
Is it like exactly 10 hours? Like I can give it 1 bottle, like 1 sample of milk, and then wait a minute, and then give it another sample, and it would be exactly at 10 hours for each one?
Yes.
Okay, so I could just do that, like wait a minute and then give the next one.
Yeah.
Okay.
That's what everybody else came up with, except they said an hour apart.
Okay.
So like if you give them a drink of bottle 1 at the start, and then an hour later give him a drink of bottle 2, and then an hour later a drink of bottle 3. Then whenever he dies, you can figure out which bottle did you give him 10 hours ago. I don't know if that's the real solution, but it makes sense to me. That's what all the other classes have come up with. If you want to make sure that's the real solution, I'll post it on Google Classroom.
That's what constant best ideas, So if you did it both balls.
Now I just gotta lock it.
Alright, about that